Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. My name is Catherine. I'll be your webinar facilitator today. I'd like to welcome you and thank you for joining us to the expansion of DZK to FXSQ and FDMQ webinar. As a brief reminder, all lines are currently on mute to prevent background noise. If you have questions during the presentation, go ahead and type them into your chat box. We'll be happy to answer at the end of the webinar. This morning, it's my pleasure to welcome Kevin Miller, VRV Indoor Unit Product Manager. Kevin, you may now begin the webinar.
Thanks, Catherine. Thanks, everybody, for listening in to the webinar about the new DZK. So this afternoon, or I guess this morning, I'm going to go through essentially an overview of the DZK product that we have for the VRV indoor units, and now we're expanding this to the single zone and multi-zone FDMQ. So if you're familiar with the DZK, this will be a bit of an overview because the introduction of the new model, which is the DZKS, is just an adjustment of the dimension of the plenum box to connect the DZK solution to the FXSQ and the FDMQ. Sorry, my PowerPoint was frozen for a second. So what are we going to go through today? The agenda just involves going through a DZK overview. We'll look at the model nomenclature, and I just want to clarify how that changes for the new DZKS series of DZK. I'll look at the model lineup and compatibility with the different VRV indoor units and the FDMQ as well. And then we'll just go through how exactly the DZK works, the features and functions, including global ventilation, local ventilation, and the integration of auxiliary heat with the DZK. Then we'll look at the available thermostats in the DZK lineup, the optional BACnet interface, an installation schematic, and then last we'll just wrap it up with a reminder of where the literature resources are for the DZK. So the DZK, if you're not familiar with DZK, the DZK is the Daikin zoning kit. And really the idea here is to take a plenum box that is equipped with damper actuators, and we can add some zoning capability to an individual indoor unit that we are connecting to a VRV system, or now with the introduction of the DZKS, we can connect this DZK with the FDMQ on the single and multi-zone systems. So the idea is essentially that the DZK consists of an insulated plenum box. So this box is designed to bolt directly to the different fan coils that we have listed for compatibility. So previous or kind of legacy current generation DZK is compatible and bolts directly to the FXMQ PB series and the FBQ series on the Skyer side. But the new DZKS is expanding that capability to bolt directly to the FXSQ TA series and then the FDMQ RVJU series. So the DZK consists of that insulated plenum box, and then we connect, or what's connected from the factory are zone dampers, each with an individual actuator. So just depending on the capacity size of the DZK and the particular indoor unit that we're connecting to, we can connect up to, or we have the ability to use up to 6 different zone dampers to provide independent heating, cooling set points to each of those individual zones. So we do have the flexibility. If you don't necessarily want to use all of the outlets from a DZK, you can cap unused outlets with a insulation plug. If you have larger zones that maybe exceed the capacity of a single outlet, we can take multiple outlets and link them together so that they respond essentially together to the input from a single zone level thermostat. From a control standpoint, the DZK wires back to the indoor unit on P1, P2. So you have very seamless control integration between the DZK's control mechanism and the indoor unit itself. So the DZK ultimately takes over the indoor unit control, and it will set the indoor unit fan speed. It will set an internal indoor unit set point. So it's something that's not really visible to the user of the DZK thermostat, but the DZK is logically sort of aggregating the demand of each zone outlet and making command decisions to control the indoor unit operation. From a control standpoint, there are 3 different thermostat options that control the DZK zone outlets. So you'll see, as I go through the presentation, you'll see a wired and 2 different wireless control options that really give essentially full flexibility to each of these zone outlets. We can have 7-day scheduling. We can program setback temperatures. These are really pretty fully featured local thermostats, and we'll go through those in more detail throughout the presentation. Last but not least, from a front-end standpoint, there is an optional backnet card for the DZK, and that really helps for light commercial and commercial projects that are utilizing DZK, in that it gives us the ability to see, control, monitor each of the individual outlets from a backnet IP compatible front end. So historically, kind of very original generation DZK, essentially if we connected the DZK in an indoor unit, we couldn't actually see the individual outlet status, room temperature, set points, etc. With the introduction of the backnet card a couple years ago, we're now able to monitor and control those individual outlets from a centralized front end. So from a model nomenclature standpoint, it's relatively straightforward. We've named this DZK, and then with the introduction of this new FXSQ and FDMQ compatible series, we're essentially changing to the DZKS, or we're adding DZKS for an FXSQ or the FDMQ compatible DZK. So the model number is DZK or DZKS, and then we'll see a 048, a 030. This just indicates the plenum box, sort of the nominal size. There's a medium size, there's a large size. And then we've also added E4, E5, E6, indicates the quantity of zone outlets on that DZK. And then the last trailing digit after the dash just is a generation designator. So current generation is -3. We previously had a -2 for 2nd gen, and the original launch several years ago didn't have any kind of generation designator. When it comes to the model lineup and compatibility of the DZK series, so on the left side of the table here, we have the existing lineup of DZK that connects with the FXMQ and the FBQ. So just if you're not familiar, I'll cover that quickly. The DZK 030 is compatible with the FXMQ 15 to 24 PB series, and then that's available with either 4 outlets or 5 outlets. The DZK 048 was compatible with the FXMQ 30 through 54 PB series. And in that case, we can choose either 4 outlets or 6 outlets. If we choose the 4 outlet option, those outlets are 8 inch in diameter. If we choose the 6 outlet option, they are 6 inches in diameter. And that pattern is followed pretty regularly throughout the DZK. The fewer the outlets, we generally use an 8 inch outlet. If you are using the option that has a higher quantity of outlets, then you generally end up with a 6 inch diameter outlet. So the new DZKS series is where we start to introduce compatibility with the FXSQ and the FDMQ. So DZKS is actually introducing a smaller format or a smaller chassis size, frame size, in that we are introducing a DZKS 015, so quite a bit smaller in regards to the total capacity of the indoor unit. And in the case of DZKS 015, we can choose either 3 outlets or 4 outlets, and that's compatible with FXSQ 15 or the FDMQ 09 and 12. The medium-sized DZKS is the DZKS 030, and in that case, we can use either 4 or 5 outlets, and that connects to the FXSQ 18, 24, and 30, and the FDMQ 15 through 24. And then the last kind of large body DZKS is the DZKS 048, which is available either as a 4 outlet or a 6 outlet plenum box, and that connects to the FXSQ 36 or 48. So just keep in mind here, you are not seeing the DZKS that's compatible with an FXSQ 54. So the plenum box size stops at the 4-ton size with the FXSQ 48. So how does the DZK work? So if you're not familiar with DZK operation, each zone has its own set point and will modulate its appropriate damper in response to that set point operation. And so essentially you have 4 different steps of capacity control. So as that set point drifts away from room temperature, the DZK will adjust the damper position open, and then as we start to bring that room temperature back down to set point, the DZK just simply modulates that damper closed. And eventually you'll just get to a point where you close the damper, where you have 4 different steps of capacity control as we open the damper position. We do have the ability to adjust the minimum and maximum opening position of the damper. So if you want to have some sort of minimum opening for ventilation, or if your zone doesn't have necessarily a complete capacity demand associated with that particular outlet size, we have that option to adjust the maximum setting position. And the percentages that you see here are approximate airflow percentages associated with each of these damper positions. So just keep in mind these are mechanical adjustments that are done in the field during installation. When it comes to the mode of operation, we have that DZK, we have several different zone outlets. Each of those outlets has its own set point and has its own thermostat. But what this means is that one of the DZK thermostats will have to utilize a wired thermostat, and we'll see those thermostat options in a bit more detail later. But one of the thermostats must be a wired thermostat, and that will be configured as the main thermostat for the DZK. And this is essentially like choosing the master indoor unit of a heat pump system. Choosing the main thermostat is what really helps drive the setting of the operation mode of the DZK. So the main thermostat can choose cooling operation, it can choose heating operation, we can choose an auto mode, we can also choose dry mode and an emergency heat mode. So I do want to describe the auto mode in a little bit of detail. The auto mode essentially takes the sort of aggregate demand of all of the different zones that are connected to that DZK, and it looks at the zone, each zone's set point temperature, each zone's room temperature, and then there's also a time aspect associated with calculating what these demands are for each zone. And the DZK will take all this information, make some calculations, and it will adjust the indoor unit's mode of operation to either cool or heat. It's relatively straightforward. So how does the DZK, we can set the mode of operation with that main thermostat, but we also have what we call user modes within the DZK. So the user modes are essentially these sort of shortcut, straightforward ways to adjust internal set point conditions or target set point conditions of each of the zones. So we'll go through some of these different user modes, and I'll kind of explain what they do and how they're configurable. But each of these user modes stores pre-configured set points for each of the zones. So when this main thermostat is or when the user adjusts the user mode on the main thermostat, or this is also something we can send via the BACnet card. But when this user mode is set, these preset commands are applied to all zones on the DZK. So just keep in mind that the main thermostat can control these. They can also be scheduled, and we can configure certain settings for these user modes in the advanced setting menu of the thermostats. So the basic user mode is the comfort user mode, and this is pretty typically used essentially as standard sort of occupied setting in commercial use. It's sort of a home setting if this DZK is being used residentially. But this is essentially your standard sort of day-to-day standard set points within the system. So the comfort user mode has adjustable set points within the range of 64 to 86 degrees Fahrenheit, and in cooling. On the heating side, it's 59 to 86 degrees Fahrenheit. There's an eco user mode, and the idea behind the eco user mode is essentially to store more efficient operating set points within the system. So typically you're going to use a higher than normal cooling set point, a lower than normal heating set point. And in the case of the allowable or kind of the configurable set point ranges for eco mode, you'll see the same thing here, 64 to 86 Fahrenheit, 59 to 86 Fahrenheit. I do want to point out what you don't see here in the eco user mode, the logic with which the DZK makes adjustments to the indoor unit, kind of internal indoor unit set point, and the logic with which it controls the zone outlets. It changes a little bit with the eco user mode, with the goal of essentially operating this system as energy efficiently as possible. So the idea is the user is storing more energy efficient set points, and the logic with which the DZK controls the indoor unit tries to optimize the efficiency of this system as much as possible. There's a nighttime user mode. This is really more ideal for residential use, but essentially the nighttime user mode automatically adjusts the set point of the system over time, again with the idea of saving energy really once the homeowner has gone to sleep. So what you'll see in the nighttime user mode is that every 30 minutes, the DZK will adjust the cooling set point up by 1 degree. So that just means over a total of 2 hours, the set point will increase 4 degrees in cooling. Similarly, in heating mode, it will decrease the set point to these lower, more energy efficient operating points. There's an unoccupied user mode. The icon there looks kind of like a man walking out of a house, but the unoccupied user mode, you know, in an office setting that's occupied, maybe people have left for the day, maybe it's a lunchtime schedule. Residentially, that's just simply you've left the house, you've gone to work, and the home is unoccupied. The unoccupied mode has a bit more of a restricted programmable set point range, 75 to 86 degrees Fahrenheit in cooling, 59 to 72 degrees Fahrenheit in heating. And it's important to note that the unoccupied mode is essentially one of 2 away modes that the DZK uses. So an away mode is a setting that the DZK uses to essentially identify that occupants have left the space. And so when the DZK is in an away mode, the system essentially allows for temporary override of the target set point. So if you were to program the cooling set point to 86 degrees Fahrenheit in the unoccupied mode, some user might come adjust the set point down. The DZK will allow that set point change to occur temporarily. So you'll have this temporary override that allows that set point to change from anywhere from 10 to 120 minutes, and then you'll revert back to that default configured unoccupied set point. So just be aware you have that capability, and we can adjust the amount of time that that set point is overridden in the advanced settings menu of the DZK. There's a vacation mode as well, really also typically a little bit more of a residential focus. but the same situation is here. It's an unoccupied set point, even more of a restricted set point range, 84 to 96 in cooling, 50 to 61 in heating. And just be aware this is another away mode within the DZK logic. So there is, maybe you have a housekeeper, a dog watcher, or something like that. They can come and override that vacation set point for a predetermined amount of time. The last user mode is a stop user mode. So this is something that essentially stops all zones, kind of turns off all zones. So all of the zones will be set to off. And when this stop user mode is implemented, all the dampers, because all the zones will be set to off, the fan will stop and all dampers will go open. So this is a useful tool to be aware of when doing testing and balancing. It can help to make sure all of those damper positions go open. Then you might disconnect the DZK, run the indoor unit fan, so that you can start to balance the air flow out of each outlet without having those dampers modulate open and closed. So just be aware, I'll discuss two different ventilation options shortly, but when the stop user mode is implemented, there's a local ventilation setting that will be ignored, but there is a global ventilation setting that will be followed even when the stop command has been initiated. So how does the indoor unit, or how does the DZK control the indoor unit fan speed? So there's an adjustable algorithm within the DZK that allows the DZK to take all of this aggregate demand and decide what fan speed we're going to send to the indoor unit. So you have this airflow control algorithm that is set as standard, or kind of standard from the factory. This is just configured as standard, but there are two other options. There's a silence option and there's a power option. And essentially what we're doing here is we are weighting the demand of the different zones, and we are essentially asking the DZK in the silence configuration, we're asking the DZK to wait until there is greater demand from all of the zones before the DZK brings the fan speed up to a higher setting. Similarly, the power setting essentially biases this logic towards higher fan speeds. And so it requires less of a total demand from all of the zones before the DZK starts to use higher fan speeds. So really the idea here is, if you want to try and minimize the noise levels of the DZK, we can use the silence setting. If we want to try to maximize capacity and get as much airflow as possible, we can use the power setting. There's a global ventilation setting that allows the DZK to try to essentially provide ventilation to all zones. So what happens is, when the global ventilation setting is enabled, there will be times in which there are no demands. Essentially, when you have no cooling or heating demand from any zone, then the DZK will run this algorithm that will allow the zone dampers to all open and energize the indoor unit fan in order to provide ventilation to all of these different zones that we're serving with the DZK. So this is a configurable setting where we can adjust essentially every 5 to 40 minutes. We will command the DZK to run the fan of the indoor unit from anywhere from 5 to 20 minutes in 5-minute increments. So as an example that we have on the screen here, we might configure every 10 minutes run the DZK, or allow the DZK to run the indoor unit fan for 5 minutes. So on the graph we're seeing here, essentially every 10 minutes, all dampers will open and the fan will energize. No cooling or heating will be delivered during this global ventilation operation. In this example, essentially upon a demand for either cooling or heating, the dampers will start to operate as typical and the global ventilation setting will be ignored. And then once we reach this point where there's no longer a cooling or heating demand by any zone, the DZK goes back into this global ventilation logic to start modulating the fan and opening these dampers to essentially run for 5 minutes every 10 minutes. There's also a local ventilation setting, and local ventilation is enabled kind of individually at the zone level. And essentially this is similar to global ventilation, except when there is no heating or cooling demand from any zone, and we can kind of de-energize the coil. Any zone that has the local ventilation active will allow that zone damper to open, and the indoor unit's fan will run so that we can circulate ventilation air to improve the indoor air quality of that particular zone. So just be aware this is something that's enabled locally, and there's a fan icon that the user will see on the thermostat. So pressing the fan icon activates local ventilation, and that fan icon will be shaded in. If they turn that local ventilation setting off, the fan icon just becomes unshaded. So the DZK also incorporates auxiliary heat control logic. So what we see here on the screen is an image of the PCB of the DZK. And you can see that there are two different auxiliary heat contact outputs. There's an auxiliary heat stage 1, there's an auxiliary heat stage 2. So this is something that's configurable within the advanced settings of the DZK. And we can essentially allow this to be configured as a 0 for no auxiliary heat. A 1 setting will equate to a single stage auxiliary heat. A 2 setting will correspond to 2 stages of auxiliary heat. Pretty straightforward. There are also settings associated in the DZK. You'll see it called first supply heat settings. And in this case, we can either allow the indoor unit to operate as heat pump as primary, or we can allow the auxiliary heat to operate as primary and then be supplemented by the indoor unit's heat pump heating. There's a third setting associated with whether or not we want to run the fan or not run the fan whenever we are engaging auxiliary heat. So just be aware there's 2 settings there. One is noted as electric, one is noted as furnace. And essentially electric means we need the indoor unit's fan to run when we have this auxiliary heat configured as electric. If you configure this auxiliary heat as furnace, essentially the DZK will recognize that we don't need to run the indoor unit when we are trying to turn on this auxiliary heat, or we don't need to run the indoor unit fan. So that might be baseboard radiators, maybe radiant panels, some other source of heat that does not require the indoor unit's fan. So next I want to take a quick look at the thermostat options for the DZK. So if you're familiar with the DZK, this is not any change for the DZK-S, but if you're not familiar with the DZK in general, then just take a look. So the first option is the DZK wired thermostat, and this is the DZK MTS-3-W. So this is a full color touchscreen display. It's about 3.62 by 3.62. It's a square design. They're about 15 millimeters deep, so relatively low profile, especially over previous generation DZKs. But the wired thermostat can be configured as either a main thermostat or a zone thermostat. So one of them has to be used as the main thermostat on the system. But if you have, a 6-zone DZK, you can have 6 wired thermostats. One will be the main, the other 5 will be zone level thermostats. It has a glass finish with a steel bezel, and this allows essentially the full range of control of each zone. Set point control, mode control, the user mode control that we looked at before, and that airflow adjustment control. You'll see those 3 control choices are starred, mode, user mode, and airflow. Those are only configurable and adjustable from the main thermostat. So these are essentially like adjusting sort of the master indoor unit operation. We're adjusting sort of master DZK control using the main wired thermostat. Either as a main or a zone level thermostat, we can enable or disable local ventilation. We can enable or disable an off timer for the DZK. And then we can also use any of these wired thermostats that are on the system to access the advanced settings menu of the DZK. I'm not going to go through all of the interface overview here on the screen, but just be aware that it's this wired thermostat is a touchscreen display. So we actually touch and control the icons on the screen themselves. But just note here that the power button is a capacitive touch button down here on the right side, kind of the bottom right of this display. I do want to point out that the color of the background of the wired thermostat does change in association with the mode of operation of the unit. So during typical cooling operation, the background color of this wired thermostat has sort of a blue tint to it. When the unit is in heating operation, and you will see that the icons change. So for instance, cooling, you'll see a snowflake icon for mode of operation. Heating, you'll see a sun icon. But during heating operation, the shade or the tint of this thermostat face becomes red. And then once all zones are satisfied and the indoor unit is no longer delivering cooling or heating, the shade of this background will become green. And that's really regardless of mode. So if the mode is cooling and all zones are satisfied, the screen will turn green. If the mode is heating and all zones are satisfied, it will also turn green. And it's a bit hard to tell, at least on my monitor here. Hopefully it's coming through differently on your monitor, but when the stop user mode has been activated. So the user mode is this middle icon on the display. When stop has been implemented, that background will turn purple. So the kind of primary wireless thermostat for the DZK is the DZK ZTS3-W. So we call this the DZK wireless thermostat. And in regards to form factor, it matches the same dimensions and depth of the main wired thermostats, 3.62 by 3.62, and it's about 15 millimeters deep. But this is a low energy e-ink screen that's backlit. So the idea here is to maximize the battery life. It is powered by one CR2450 battery. But the idea is to design a thermostat that maximizes the battery life of the thermostat. So it has the same glass finish and steel bezel. And in this case, the screen itself is not touchscreen. There are capacitive touch buttons that surround the screen. And I'll go through those in just a little bit of detail. But this also allows the user to control set point, enable or disable local ventilation, enable or disable an off timer. And it does have, kind of depending on the construction, up to 130-foot wireless signal range and about a 2-year battery life on that CR2450 battery. So this is kind of an overview of the different icons that are on this wireless thermostat. I'll just quickly go through. The mode icon is displayed here. Keep in mind this is a read-only display of modes because this can't be a main thermostat. You can't actually control the mode of operation, but you can monitor the mode of operation that's being commanded by the main thermostat. So we can see mode, we can see the user mode, and we can see the current airflow control setting. The large number in the middle of the screen will display the current set point. We can see the zone number and the current room temperature and relative humidity measurements of the zone. And then at the bottom left of the screen, we'll see whether or not local ventilation is enabled or the on-off timer. I do just want to note again that the control of the wireless thermostat is done with capacitive touch buttons that are around this, kind of the edges of the display. So on the left side, you'll see a menu button, and this is what allows zone navigation. So if for some reason the main thermostat fails, we can actually navigate to other zones using a wireless thermostat and control other zones. But this menu is where we'll also access the local ventilation, the on-off timer, and the thermostat information. On the right side of the screen, there's a series of graduated lines. These are the capacitive touch interface that allows the user to adjust the set point And this is also used to make selections from the submenu. I don't have an image on the screen, or I don't have an image of this, but essentially when somebody is accessing the menu options will be aligned with these graduated lines, and the user can simply press in that graduated line to make a menu selection. The air zone icon at the bottom of the screen is used as a button. So this is used to wake up that thermostat when it's in the screensaver mode. It's also used to confirm menu selections. So just be aware, the air zone icon, it's not just a logo, it's also a button. And then at the bottom right of the screen, the power icon performs the same function as we saw on the wired thermostat, in that we're just turning on and off that zone. The third option for the DZK thermostats is the wireless light thermostat. That model number is DZK LPS-3-W. So in this case, same footprint again, 3.62 inches by 3.62 inches, about 15 millimeters deep. And the idea here is to have a simple, low-cost wireless zone thermostat that has a very limited functionality to limit the amount of control that the user has over that zone outlet. So the wireless light thermostat features colored LEDs that indicate the operation status of the thermostat. It also is utilizing capacitive touch buttons to allow the user to make adjustments to the set point. And what the wireless light thermostat offers is the ability for the user to adjust essentially an offset from a base set point that is programmed by any of the main wired thermostats. So essentially that wired thermostat will set a base set point. We'll just say, for example, 70 degrees. We can use this wireless light thermostat to adjust up or down in 1 degree increments, 1 degree Fahrenheit, for a total of plus or minus 3 degrees from that base set point. Do just be aware, we can adjust that increment from 1 degree to 2 degrees. So we can ultimately have up to plus or minus 6 degrees Fahrenheit, essentially 3 degrees Celsius. So the wireless light is powered by that same CR2450 battery, also has an approximate 2-year battery life and up to 130 feet of wireless signal range. So when the user is actually using this wireless light thermostat, we looked at the shading of the main wired thermostats. There's also a similar shading scheme that's indicating the mode of operation of the wireless light thermostats. So the power button, it's used to turn on and off the zone, but this also indicates the operation mode of the DZK in the indoor unit. So similarly here, red will indicate heating operation, blue will indicate cooling operation, green just indicates that the set point has been satisfied and that fan coil is no longer energized as either cooling or heating. And then this icon will also turn purple if the stop user mode is implemented. It is important to note that when the user touches this thermostat, it essentially wakes up. So the first touch will be sort of a wake-up call to the thermostat. And when the user does that, the power LED, if it remains solid, that means the zone is active. If that power LED kind of does a slow flash, that means the zone is deactive or has turned off. So first touch is a wake up so that the user can sort of assess the status of that zone. If they can't already tell the zone is on or off, they'll wake up the thermostat, and then a second press will either turn on the zone or turn off the zone. So there are graduated lines to the left and right side of the power button. And what these lines do is they indicate that offset adjustment from the base set point. So essentially that wireless light receives its base set point from any of the wired thermostats. We can actually adjust that base set point from any of the wired thermostats. And then we can adjust in that +1 or -1 increment for a total of +3 or -3 Fahrenheit. And essentially what happens is when the user taps this region of the graduated lines above the set point, we'll see some white LEDs that are reflecting that the user has adjusted the set point above the base set point. So it gives the user the ability to see how far they've adjusted from base set point and to turn on and off the zone. But it's very limited functionality. This is something where you want to use this where we kind of need restricted access, or you don't necessarily need a fully featured zone level thermostat. So the BACnet interface is something that's an optional add-on or field installed addition to the DZK. It's a small plug and play card that plugs right into that DZK's main board. So it installs directly into the enclosure. There's nothing additional that's needed to bolt on to the DZK in any form or fashion. We just plug this BACnet interface directly onto the DZK's main board. So this is a plug and play option that's compatible with BACnet IP, and essentially it supports change of value notification. And do note that these are generation specific. So in the case of the current 3rd generation DZK, there is a 3rd generation DZK BACnet board, which is the DZK BACnet-3. So if you had something in the field that's a generation 2, we do have a 2nd generation BACnet card, but they are not forwards or backwards compatible. So we have to use a 3 with a 3, a 2 with a 2. What you see on the screen here is an overview of the network topology with the DZK BACnet card, and you have a couple of different options. In the case of utilizing the BACnet interface for VRV, in this case, we don't actually connect the DZK's BACnet card downstream of the Daikin BACnet interface. So in this case, the BMS will wire directly to the DZK BACnet card, which is plugged into the DZK in the indoor unit. Another example is to utilize the ITM with the BACnet client. And in that case, we can take the BACnet client and we can command and control the DZK by wiring to those DZK BACnet cards. I just want to point out the options or the availability of options for the DZK BACnet card. So at a system level, there are 14 different BACnet points per DZK system. 12 of those are read-only, 2 of them are read-write points, but you are essentially monitoring system-level operation, whether the indoor unit is on or off, whether the global ventilation setting that we talked about is active or deactive, whether system auxiliary heat is active or deactive. We can see a lot of system information, but when it comes to reading and writing kind of direct control, we can control the DZK's operation mode, or we can control the DZK's user mode with the system level BACnet points. There are also 12 zone level BACnet points also available. 6 of those are read-write, 6 of those are read-only, and this is giving us the ability to turn on and off a zone, enable that zone's local ventilation, set that zone set point. We can read that zone's room temperature. Really everything that you might want to see from a zone level, we can see with this BACnet interface. So just keep in mind, very powerful, even for light commercial applications, because it gives you that ability. If, especially if you use something like iTouch Manager and BACnet Client, we can still command control from a centralized location each individual zone on the DZKs. So from an installation standpoint, I just want to quickly look at sort of the architecture of how we connect DZK to the rest of the VRV system. So I'm just going to kind of go sort of from a high level. You know, we've got the VRV system connected on F1, F2 to the indoor unit. We do have to have a navigation remote controller connected to that indoor unit on P1, P2. But we connect that indoor unit from P1, P2 back to the DZK's main board. So there's a small daughter board on the DZK that has a P1, P2 integration connected to it. So we connect on P1, P2. We have the stage 1 and stage 2 auxiliary heat contacts. The DZK does require 120 or 240 volt single phase power. So you'll see that power landing point on the DZK's main board. There's a wireless card that's built into the DZK's main board, so we can communicate back to that wireless card. Kind of everything goes from the zone level wireless stats back to the DZK's main board. At the top of the DZK's main board, you'll see these bus connections for the wired thermostats. So in this case, you see 3 different connections. So each of these connections can handle up to 2 different wired thermostats. So the maximum possible zones we have on DZK today is 6. So we could wire 2 thermostats back to each of those landing points. There is a switch on the DZK's main board that you should be aware of, SW1. This is something that we can use to open the wireless radio channel to start allowing the wireless thermostats to connect to the DZK, or we can press and hold that to essentially reset the DZK's main board. This gives you kind of an idea of exactly what the wiring architecture looks like for the DZK and how it integrates into the system. So don't forget, as far as resources, there's a selection guide on Daikin City, installation manuals, user manuals. We've updated flyers and all of the installation and operational data, additional submittal data sheets to include the DZK S models. And also just be aware that there's a compatibility matrix on Daikin City as well that helps to simplify if there's any confusion about what goes with what as far as DZK generational compatibility, indoor unit compatibility. There's a compatibility matrix loaded into Daikin City as well that will help to maybe clear up any questions about what can or can't be used. The easiest thing to remember is 3rd generation DZK always connects with 3rd generation thermostats, 3rd generation backnet cards. So to wrap up, the DZK offers a solution for easy zone temperature control from a single fan coil and does feature optional front-end integration to any BACnet IP compatible building management system. So really this gives a kind of a good, I call it a budget conscious solution if you want to add zoning capability, but you want to try to minimize cost. DZK is also something that gets used commonly if ASHRAE 15 becomes a challenge on a project and we are trying to give zone level control, but we need to duct to several rooms because we're serving very small rooms. The DZK can be a good solution to address those ASHRAE 15 limitations on larger systems. So the DZK is a bolt-on accessory that is now expanded to the FXSQ and the FDMQ. It already existed for the FXMQ series and the FBQ series. And there are 3 different thermostat options, the wired, the wireless, and the wireless light options that we looked at. And that gives us simple and intuitive control for up to 6 different zones, just depending on the capacity of your fan coil. And that BACnet card gives us optional front-end integration capability. So now we can see, monitor, and control each individual zone from a front end or from the iTouch Manager if we are using the BACnet client option. So with that, I think I'll wrap it up, Catherine, and just open the floor for questions.
All right, great. Thank you so much, Kevin. So, excuse me, just a couple quick reminders, and I'm sure you're all familiar with them. 1, if you have any questions, please use your chat box. We'll be happy to answer your questions. I did want to mention, of course, you will receive a follow-up email a little bit later today with the link to this webinar recording. So if you'd like to refer back to it or share it with someone who might be interested, it will be in your email later today. And also, of course, there is a post-webinar survey, so feel free to provide some feedback. So a few questions waiting here. One is, are there any plans to also add the FXTQ and FTQ?
That is a great question. There are plans, so we've started discussions. Essentially, the goal was let's get DZK-S launched for the FXSQ, and now we've started discussions for something that we call or consider a loose damper solution. So the roadmap right now does not involve a plenum box. It involves really sort of a loose damper solution where we're providing, or the idea is to provide individual dampers and a control board so that we can better integrate with FXTQ and FTQ. I don't have any timeline to share really at this point, so just keep an eye out for that down the road, and that should be really the next evolution in the DZK.
And there's actually a comment from the field on this in regards to the FXTQ and FTQ units. You can use AirZone directly. FYI, just buy a damper and thermostat without the plenum box. And there's a little smiley after that. So thanks for that comment. Okay, another question. Will the DZK work with the new FDMQ RVJU9 that will be replacing the FDMQ RVJU?
It should. I'm not familiar that there was an RVJU9 coming out. I'll have to chat with Connie and just understand what the differences might be. But as long as it's P1, P2 protocol, and as long as the dimensions are not changing, then there should be no issue using this DZKS with the new model, but let me just verify what that is, and I'll follow up.
Okay, so Gary will get with you offline on that one. What is the max subzone on one control?
I guess I'm not sure I understand the question. So maybe I'll give as much information as I can. So if you have, let's say, 6 zones, you still have to have 6 thermostats because each thermostat has the room temperature thermistor for that particular zone. So if you don't necessarily need control in every space, you still have to measure room temperature. So what I'd recommend is using the wireless light thermostat. However, essentially any of the wired thermostats can be used to navigate to other zones. So you could use a wireless thermostat and it might be connected to zone 1, but you can actually access all the other zones, control all those other zones, make set point changes, but you still have to have that local level of temperature monitoring so that that particular actuator for that zone knows what its temperature delta is and can adjust that zone's position.
Okay. Any problems with DZK sharing power feed for the indoor unit on the VRV applications?
I don't believe so, but that's probably something to sort of defer to local code. I'm not exactly sure what the actual code implications would be if you just tap that right off of the indoor units L1, L2, but I believe that's relatively common.
Okay. And then a couple questions in relation to dampers. Are the damper motors the same for all 3 series, 1, 2, and 3? And how many dampers per control?
The dampers are the same for all 3 series. So the spare part that was set up when DZK originally launched, that is still the same damper actuator that we use as a spare part, and it's still the same factory actuator that's connected. As far as the number, I don't think that there's a practical limit. I mean, in theory, let's say you bought a 6-zone outlet. I don't believe that there's any restriction if you tried to connect 5 of those to one single thermostat. But to be honest, I've never tried that myself, and I've never tried to see. I've never kind of worked back with AirZone to understand. I know you can do 2. I'm 99% sure you can do 3. I don't know if there's any limit to doing 5. My assumption is there is no programmed limit, but I'll confirm that as well.
Okay. And getting back to the item you're going to talk to with Connie, I think it's RVJU. The 9 is just a suffix change to match the outdoor model SKU change. So just FYI. Does DZK BACnet card continue to communicate room level info if the VRV CU has stopped communicating? For example, if there's a PCB failure, communicating unit. For example, if there's a PCB failure?
I believe it does, but I'm not 100% sure. I'll need to check.
Okay, Sean, we'll get back with you on that one. All right. So again, that's another comment. So I think I think that we have all the questions, and certainly if folks have other questions, go ahead and send them in. If you think of other questions, you can always tuck them into your post-webinar survey as well. And of course, I'll be forwarding everything over to Kevin for his review. And if there's anything we need to follow up on, we will get back with you folks on that. Kevin, anything you'd like to say in closing today?
No, I appreciate everybody listening in. And again, if you have any questions, just feel free to reach out to me.
All right, perfect. Well, I just wanted to thank you for bringing us this presentation, and for everyone who joined us today, whether you're here live now or later on the recording, we appreciate it and look forward to talking to you on another webinar soon. Have a great rest of your day, everybody. Bye-bye.